All right, this is for anybody that needs help with the scatter plots category. Here we go. Which scatter plot shows data with negative association, two outliers, and clustering around x equals 7? Let's go ahead and break these down one thing at a time. First thing is we're looking for a scatter plot that shows a negative association. Of our four choices, three of them show negative association. A, you notice that the grouping of dots generally goes down as x increases. So as you read from left to right, it's going downwards. That's negative association. As the x values get higher, the y values are getting lower. So that's negative association. What other graphs look like that? This scatter plot has a very slight, but it's definitely there, negative association. As x gets higher, y is getting lower. This one also has negative association. As x is getting higher, y is getting lower. B is the only one that does not show a negative association. Here, it's going up and to the right, the grouping of dots, that is. So that is a positive association. As x is getting greater, y is also getting greater. So if we're looking for a negative association, our choices are A, C, and D. The next thing it needs is two outliers. An outlier is a point that does not fit the rest of the data. So if we look at graph A, there's an outlier right here. That point's kind of off by itself, so that's an outlier. And this point down here is also an outlier. So graph A does have two outliers. We'll go ahead and take a look at the other choices. C, I only see one outlier down here. It's just this dot. No other dot is way away from the rest of the group. So choice C does not work because it doesn't have two outliers. It only has one. In choice D, I see two outliers for choice D as well. Up here, this dot at 8, 8 seems to be an outlier. It's not with the rest of the group. And this one down here at 0, 1, that also is an outlier. So now we've eliminated B and C. So the answer must be graph A or graph D. The last thing is we're looking for clustering around x equals 7. Now, cluster just means a kind of more tightly packed group of points than we would see elsewhere. So let's look at where x equals 7. X equals 7 is right here. If I follow it up, I don't see a particularly packed group of points right here. It's about the same density as the rest of the scatter plot. So this doesn't look like a cluster at x equals 7. If I go down to D and I go to 7, you see all these points right here. That's a very high density compared to the rest of the scatter plot. So D is going to be our answer. It's a negative association, which means the points go down as we go left to right. As x gets greater, y gets lower, so it's a negative association. There are two outliers, one there and one there. And finally, there's a cluster of points around x equals 7. So that fits the three things we're looking for. Next problem. All right, for the number 3 here, Teresa's mom rented a car. She decided to track the number of miles driven and the amount of gas remaining in the car. She recorded her data in the table. You see the table here. How would this data be interpreted on a scatter plot? Now, you could put all of these points into a scatter plot and then read it, but you don't have to. You just have to take note of what's going on with the numbers. As the number of miles driven increases, what's happening to the amount of fuel remaining? As the number of miles driven increases, the amount of fuel remaining decreases. That is a negative association. When the values for one of your variables goes up as the other variable goes down, that's negative association. If they were both going up at the same time, that would be a positive association. Another one of the choices in here says that there would be a constant association. That would be if one of the variables was increasing, but the other remained the same. And finally, the last one says there's no association. Well, there's definitely association here because there's some consistency as the number of miles is driven increases, the fuel remaining decreases the entire time. There's no spikes where it seems to go up and down or seemingly have nothing to do with the other. There's definitely an association there. So this is a negative association. So find the one that says negative association, which in this choice is A. A scatter plot would show a negative association between the number of miles driven and the amount of fuel left in the gas tank. Now, I've taken the liberty of copy pasting this table into a spreadsheet and creating a scatter plot based on those results. So if you'd like to see what the scatter plot looks like, here it is. The number of miles driven and the fuel remaining in gallons. And that is what we have here in the scatter plot. So 40 miles driven, 15 gallons remaining. That's this point right here. 80 miles driven, 13 gallons remaining. That's this point right here. And you can see it's a pretty consistent downward slope. And if you use Google Sheets, you can go over to the series option and you can scroll down and hit trend line. And there's a trend line. So the general trend as you go from left to right is clearly going downwards. You certainly don't need the trend line or line of best fit to notice that, but it does help some people visualize the pattern in which the data is going. So that's a negative association. All right, next problem. This problem is very simple. All you need to do is take the data from the table and see which scatter plot is accurately plotting that data. So let's go through it. The first data point is week 1, attendance 65. Now, each one of these scatter plots that we have to choose from measures the weeks on the x-axis, and they each measure attendance on the y-axis. So we're simply looking for the point 165. So let's go ahead and look for those. Here, week 1 would be halfway between 0 and 2. You notice that they've labeled every 2 weeks here, so the lines that do not have those labels would be the odd numbered weeks. And then 65, that looks about where 65 would be, seeing as how it's below 100 and above 50. So 165 does appear on the scatter plot W. But on scatter plot X, there is no 165. It's 1, and that looks to be about 150. You can see it between 100 and 200. So scatter plot X is not going to be one of our answers, or one of the possible answers. Scatter plot Y, 165. You can see that's very similar to scatter plot W, so 165 appears there. But on scatter plot Z, again, it's 1 and 150. So scatter plot X and scatter plot Z do not fit even the first data point. Next data point, 2, 100. 2, 100 shows up here and here. So our two remaining choices, scatter plot W and scatter plot Y, both have the second point, 2, 100. 3, 150 is the next data point. 3, 150. And then 3, 150. So again, W and Y both have those same 3 points. Next one, 4, 220. 4. And then this line right here is 200, and that's a bit above it, so that looks to be about where 220 would be. What about graph Y? Here's 4. Where's 200? Well, this point is at 300, so that is not accurate. So scatter plot Y is not going to work. We've got scatter plot W now as the only remaining option. And if we went through the rest of these, we would see that they do match up, even though it certainly doesn't need to be done that we have to go through each of the remaining options because we've already eliminated choice X, choice Z, and choice Y. But if we wanted to be thorough to make sure that we were not making a mistake, we could simply read through the rest of the table and make sure that the points match up. So week 5, 80, and there's 5 and 80 right there. 6, 120, right there, that matches up. 7, 190, 7, 190, and finally 8, 100, and that matches up. So all of the points appear on a scatter plot W. All right, next question. A dancer learned some new choreography for a dance contest. The instructor kept track of the number of missteps he made. The results are shown in the scatter plot below. So take a look at this scatter plot. It appears as time gets greater, the number of hours increases, the number of missteps is going downwards. So with only 1 hour of practice, the number of missteps is up here around 35, almost to 40, above 30. 2 hours in, less than 30, 3 hours in, less than 25, 4 hours in, less than 15. So as more hours are put in, the number of missteps, and missteps or mistakes, goes down. That seems to make sense because the more practice you put into something, the better you get at it. So which statement is supported by the data in the scatter plot? Let's read through them. A, as the practice time increases, the number of missteps tends to decrease. That's absolutely true. Again, increases time, decreases missteps. That's what that says. Let's read through the other ones and we know why they're wrong. As practice time increases, the number of missteps tends to increase. That's not true. Increasing would mean that the number of missteps is going up, and the number of missteps is clearly not going up. as practice time increases. C, as practice time increases, the number of missteps tends to stay the same. That's not true either. It would be in a relatively flat line instead of a downward sloping line. Next one, there is no relationship. There's clearly a relationship because you can see a pattern in the data. If I were to put a point, say, over here, you would look at that point and go, hey, that point is an outlier. It doesn't fit the rest of the data. Since we have a clear pattern here, there definitely is an association between the time and the number of missteps. So A is our answer. Next question. The data represents the ages and heights of 7 neighborhood children. So the children's heights, their age and their height in inches. So age, an 8-year-old is 37 inches high, another 8-year-old is 39 inches high. There's a 10-year-old that's 48 inches high, a 12-year-old that's 50, a 13-year-old that's 53, a 15-year-old that's 62, and a 16-year-old that's 67 inches tall. How would this data be interpreted on a scatter plot? Again, you could make an actual scatter plot here and look at it, or you can just take a look at the numbers and predict what's going to happen. This is going to show a positive association between age and height, because as the ages increase, the heights increase as well. The older the age of the child, the taller they are. So this shows a positive association. Let's find a choice that says that those are going to have a positive association. Choice A scatter plot would show a positive association between the children's ages and their heights. That's absolutely true. Let's read the other ones and see why they're not true. A scatter plot would show no association between the children's ages and their heights. There absolutely is going to be an association because there's consistency in that both are increasing. That means that they're going to have a pattern of sticking together and they won't bounce around all over the place. If the numbers bounced around all over the place, then you would be able to say, hey, it doesn't seem that one's affecting the other. But clearly here, since age is going up and height is going up consistently, there is an association. C says a scatter plot would show constant association. Again, constant association would mean that as one increases, the other stays the same. That's not true. And a scatter plot would show a negative association. That would be as if one variable increased, the other variable decreased. That's not what's happening here. That is not what's happening here. Both numbers are increasing together simultaneously. So it's a positive association. All right, next one. A biology student is conducting an experiment on the average amount of rainfall per month, where the amount of rainfall is measured in inches. The student collected data from January through November. The student's data is shown in the table below, where January, the start of the experiment, is represented as 0. Use the data to construct a scatter plot, then answer part B by placing a point in the circle of the correct statement about the data. So first, let's make our scatter plot. Our first point is 0 for the month since the experiment began, and 1.5 inches. So I go to point, because a scatter plot is a bunch of points, and I want to go to month 0 and rainfall 1.5. The months are on the x-axis, and the rainfall is measured on the y-axis. So 0 is the far left of the x-axis, and 1.5 is right there. So that is the point 0, 1.5. We'll go through and put the rest on here. 1, 2.0, it's right there. 2, 2.5, it's right there. 3, 3.5, it's right there. 4, 4.0, it's right there. 5, 3.5, it's right there. 6 and 4, it's right there. 7 and 3.5, 8 and 3.5, 9 and 3.0, and finally 10 and 2.5. Okay, so now we're going to place a point in the correct statement down here. E. The data represent a linear association, or the data represent a non-linear association. And the answer is non-linear. There seems to be grouping here. There seems to be a bit of a pattern. You can't draw a straight line through it to represent it. Therefore, it's a non-linear association. Linear association is one where you could draw a line and it essentially would go through it. Like this is a linear association from a previous problem, because we could draw a line that doesn't fit the points exactly, but it models it fairly accurately. If we were to do that on this scatter plot, there's no way we could draw a straight line that represents it accurately. All All right, here's another one. Which of the following best describes the relationship between the variables on the scatter plot below? Well, there clearly is an association, and as the x increases, y tends to increase as well. That is a positive association. Let's read through our choices. Positive and negative? You can't have a positive and a negative association at the same time. No association. Well, there's clearly an association because there's grouping here. You can see that there's spots where the data fits. You wouldn't put a point way up here because that clearly doesn't fit the rest of the pattern. If there was no association, there would be no way to predict where the points belong. So clearly, since there's grouping here, there is an association. It's not a negative association because negative associations mean that as one variable increases, the other decreases, and that's not what is happening here. It is positive association. As one variable increases, so does the other. All right, next up. The scatter plot shows the average monthly temperature outside and the cost of the natural gas bill for a business owner or for a business for over 20 months. So we've got the gas bill measured on the y-axis, and we have the average monthly temperature measured on the x-axis. Decide whether this statement in each row is true or false. First statement. There is a cluster around the point 60, 200. Now this is an ordered pair. Clearly, 60 is our x-coordinate, 200 is our y-coordinate. So let's find that point. 60 and 200. Is there a cluster? And yeah, there does appear to be a cluster. Here's 7 points right here all around that. And that's more tightly packed together than we see in the rest of the pattern. So there is a cluster. That's what a cluster is. It's a more tightly packed group of points than you see throughout the rest of the data. Next statement. There is an outlier at the point 15, 275. If we go 15, 275, there is a point right there. And that doesn't fit the rest of the data. All the other points that are around 15 are way up here in the 400s. So this point doesn't seem to fit the rest of the data. So that is definitely an outlier. So that is also true. Next, the data shows a positive association between the average monthly temperature and the natural gas bill. That is false. A positive association would show that as the average monthly temperature increases, the natural gas bill also increases, but that is not what's going on here. As the average monthly temperature increases, we have a downward sloping line. The natural gas bill is going downwards as we look at it from left to right. So as the average monthly temperature increases, the natural gas bill decreases. That is a negative association. This is positive association. That's false. Final statement. The scatter plot shows a non-linear association between the average monthly temperature and the gas bill. That is also false because you can draw a line that doesn't fit all these perfectly. They're clearly not all in a straight line. But if I drew a straight line from right about here, straight through all the middle of this data, it would model it pretty well. So this is a linear association. Statement down here says that it's nonlinear, so that statement is false. All right, one more. Which of the following best describes W on the scatter plot below? Find W, it's this little point way up here. Now we've already covered this so far in this video. That is an outlier. What are these other things, just so we know? A cluster is a tightly packed group of data points that's more tightly packed than the rest of the data, and that looks like what we have at X. This is a cluster. A nonlinear association, well, that's not true. This is a linear association. We could draw a line that would model this fairly well, and it is a positive association overall, not negative. This specifically was asking about point W, and point W is a point that doesn't fit the rest of the data. All the rest of the data is in this pattern over here, whereas W is way up into the left, not nearly in the pattern with everybody else, so we call that an outlier. All right, I hope you have good luck with this topic and work hard.